What's up, everyone? How you doing? How you doing? This is Mr. Richardson coming at you live through the power of the internet. What we're going to do today is solve a system of equations using the substitution method. Well, we need some key definitions to get started. First definition we need is, what is a linear equation? A linear equation is one of those things that students say you can put into y equals mx plus b form or slope-intercept form. It's essentially an equation that when you graph it, it forms a line. What we're doing today is solving a system of linear equations. That's when you have two or more equations that you're going to solve at the same time. Today, for our purposes, we're always going to solve two linear equations at the same time. And what is the solution to one of these systems of equations? Well, it's that coordinate pair, that point that's there when the two lines intersect. It's that point there in the middle. We're going to solve this algebraically today using a method called substitution. Here are the steps. Step 1, get one of the equations in terms of y. You want that first equation to say y equals. When you have one of those equations that says what y equals, you plug what it equals into the other equation for y. At that point, all of the y's will disappear, and you can just solve for the x values that are left. After you finish solving for x, you're not done. You need to find the other value. So you plug that x value into either original equation to find the y, and finally write your solution as a coordinate pair. These steps would work if we interchanged x and y everywhere that it is, meaning I could have solved an equation in terms of x, plugged what x equals into the other equation for x, and so on. Let's get right into a problem. I want to solve this system using the substitution method. Step 1 says solve one of these two equations in terms of y. Well, if you look, the second equation, the green one, is already y equals, so that's done for us. So in step 2, I can take what y equals 2x plus 5, and I can plug it into the other equation for y. So when I rewrite that purple equation, instead of saying 3x plus y, it will say 3x plus 2x plus 5 equals negative 5. Once I've done that, I can now just solve the resulting equation for x. Here, there's no value outside of the parentheses to distribute, so I can just go ahead and combine like terms. 3x plus 2x will become 5x. Now separate variables and constants. Subtract 5 from both sides, we get negative 10. Divide by 5, I get x equals negative 2. Are we finished? No, 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 no. We got to figure out what the y value is here. So I can plug x into either of the original equations to find y. I'm going to use this green equation. It seems to be a little simpler. Plug x in here. 2 times negative 2 is negative 4. Negative 4 plus 5 is 1. I now know that y equals 1. The solution to this system of equations is the coordinate pair negative 2, 1. Seems pretty easy, huh? Let's have you try one on your own. See if you can solve this system of equations. First step is to get y by itself, but look, it's already done for us. So I can take what y equals 2x minus 5, plug it into the other equation here for y. So instead of saying 2y equals, it will now say 2 times 2x minus 5 equals 6x plus 4. Let's do that. Here, I have to distribute. I have this constant term out here. 2 times 2x is 4x. 2 times negative 5 is negative 10. Now I have to start separating variables and constants. There's a few ways to do that. I could subtract 4x from both sides, add 10, subtract 6x, or subtract 4. I'm going to subtract 4x. 6x minus 4x is 2x. Then I need to move this positive 4 to the other side. Subtract 4, I get negative 14. Finally, divide by 2, I get x equals negative 7. At this point, we're not finished. We still need to figure out what y is. So I'm going to plug this x value into either original equation to solve for y. I'm going to use the green equation. It's a little simpler. 2 times x, or 2 times negative 7, is negative 14. Negative 14 minus 5, negative 19, making our solution the coordinate pair, negative 7, negative 19. Let's try another one. See if you can solve this system of equations using the substitution method. Here I don't have y by itself, but just as good, I know what x equals. X equals negative 2y minus 1, so I can plug what x equals into the other equation for x. So instead of rewriting the purple equation as 2x minus y, I can write it as 2 times negative 2y minus 1 minus y equals 3. Now we need to distribute. 2 times negative 2y is negative 4y. 2 times negative 1, negative 2. Combine like terms. Separate variables and constants. Divide by negative 5, and I get y equals negative 1. Am I finished? Don't think so. Still need to figure out what x is. I can plug y into either equation. I think it's easier to use the green equation here. Plug in negative 1 for y. A negative times a negative is positive. 2 minus 1 is 1, and I get my solution of 1 comma negative 1. Make sure when you do this, you're putting the x coordinate in the front part of your coordinate pair and the y value in the second part. Let's try one final problem. See if you can solve this system of equations using substitution. First step here is I need to have either y equals or x equals, and for the first time I don't. If I look at the first equation, it's going to be pretty simple to get x or y by itself. I'm just going to rewrite it here. If I want to get x by itself, I could subtract y from both sides. If I want to get y by itself, subtract x from both sides. That's exactly what I'll do. If I subtract x from both sides, I get y equals negative x plus 3. Now that I know what y equals, negative x plus 3, I can plug it into the other equation for y. So instead of writing 2x plus 4 times y, I'll write 2x plus 4 times negative x plus 3 equals 8. Here I distribute the 4. I get negative 4x plus 12. Combine like terms, I get negative 2x. Separate variables and constants by subtracting 12, I get negative 4. Divide by negative 2, I get x equals 2. Am I finished? No, 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 no. Got to plug x into one of the original equations to find the y value. Here, I'll plug x in here. I get negative 2 plus 3, which is 1, and my solution is 2, 1. I hope this video here has helped you understand how to solve systems of equations using the substitution method. Until next time, see you then.